Okay, good morning, everybody. So this would be our last meeting before the reading break. Yay, vacation mode na. Naghahanda na tayo itapon lahat ng mga akad things for 1 week. Unless you are planning to work during the reading break and catch up with your ACADS. But I suggest you take probably a couple of days, 1 or 2 days para mag-relax man lang, to re-energize yourself and to enjoy. Kailangan natin every now and then ng tawag doon, ng relaxation, alright? At makabawi mula dun sa mga stress at pagod na nararamdaman natin all throughout the uh, the half of the semester, ano. And I don't know, sa inyo ko ba na-share yung yung concept ng Pareto principle? Probably those in OR already know this. Or hindi ko alam kung sa inyo ko to na nabanggit last time. Pero sabi sa Pareto principle, yung traditional 80-20 model. So, ibig sabi niya, uh, 80% ng ating productive output or 80% of the most significant outputs that we have were produced during the 20% of our working time. So ibig sabihin, dun sa kakaunting window na yon, dun sa 20% ng ating productive time, dun nanggagaling yung 80% ng ating pinaka mga magagandang resulta. All right? So that means we are most productive in just as little as 20%, tapos dun nanggagaling yung as much as 80% of our work. That's why meron tayong tinatawag na power hour. Ano? So sa oras na yon, sa window na yon, doon natin nakukuha yung ating pinaka magagandang results, or that's the time when we are most productive. Siguro ito yung nahanap kong excuse para doon sa aking prinsipyo na pagka hindi ko feel magtrabaho or I'm not feeling too inclined to do some heavy work, I really don't work at all. Kasi nasa isip ko, niloloko ko lang yung sarili ko. If I'll do something during that time that I'm not comfortable working, haphazard or magiging mediocre yung output na ibibigay ko. So, ang aking excuse ay magtatrabaho na lang ako kung kailan ko gusto kasi doon ako pinaka-produktibo, doon ako mas maraming nagagawa, mas efficient kung naki-carry out yung mga task ko at mas maganda yung output. Alright? So, kaya minsan, hindi pala minsan, hindi ako nagi-guilty na say, halimbawa, buong Friday afternoon natutulog ako or buong Friday afternoon nanonood lang ako ng Netflix. Kasi feeling ko, pag nagtrabaho ako nun or nagpanggap ako na magtatrabaho, hindi rin ganun kaganda yung output. So, i-enjoy ko na lang yung sarili ko instead na magpanggap na nagiging produktibo. And sometimes I find my most productive hours, say, 11 p.m. to 3 a.m. Kasi doon maganda magtrabaho kasi tahimik, malamig yung simoy ng hangin, ano. So, yeah, at ako na lang yung gising sa bahay. So, pwede, walang nanggugulo sa akin. So, parang ganun. But anyway, so I hope you also have that luxury. I know pag students, wala pa tayong ganun masyadong luxury of flexibility in terms of time. But again, please use some of the at least some of the reading break to relax or energize para ready kayo pagbalik natin after the reading break, because on the other side we're gonna have the midterm exam, and that's on November 7, 4 to 6 p.m. So if you have some conflicts, pakisabihan na kagad, all right? But I hope you already made arrangements to be on campus on November 7th. Medyo late in the afternoon kasi yung iba sa inyo ay nagba-math 174. May laboratory classes ng 1 to 4. Some might be having NSTP classes. That's why we decided it's going to be 4 to 6 p.m. na lang ng November 7. It's hard to schedule during other weekdays. So, kaya yun na yung optimal na schedule na napili namin. So, just let me know if you will have problems with that so I can make some arrangements as early as possible. Kasi otherwise, i-expect ko na nandun kayo lahat, magpapakita kayo sa November 7. And probably that's a nice opportunity for us to meet each other in person, ano? Kasi yung iba sa inyo, actually parang lahat sa inyo hindi ko pa nami-meet personally, ano? So that would be our time to meet each other. But anyway, the proposed coverage of the midterm exam, or basically it was proposed to be what do you call this, departmental among the 3 Math 151 sections this semester. At ang initial talk namin ay hanggang section 3.7, yung coverage ng midterms. So today we'll do sections 3.2 and 3.3. So I'm still thinking if I will haggle a little bit na pauntiin yung coverage. Pero meron pa naman tayong isang linggo after the reading break. So we can probably talk about some parts of sections 3.4 to 3.7 by then. So aabot tayo. Pero pag-isipan ko pa, titingnan ko kung gaano kahaba yung 3.3 and 3.7 and I'll gauge how much time I need to discuss that at saka kung kakayanin niyo bang aralin siya say over the weekend before the exam. But anyway, I hope you are starting to review kasi medyo madami-dami yung coverage. Maraming mga methods. At actually, marami kayong prerequisite topics na kailangang i-review, right? Natutunan natin in the exercises, in the homeworks, kailangan magaling tayong mag-integrate, magaling tayong mag-differentiate, right? Kasi basically, kapag meron kang separable differential equation, or meron kang integrating factor, or pag meron kang exact differential equation or something that is reducible to an exact differential equation, kailangan mo mag-integrate, kailangan mo mag-differentiate. So kailangan yung balikan itong mga natutunan nyo sa Math 30 series. Ano? So kaya medyo, sana ngayon sinisimulan nyo na. What I'll do over the reading break ay mag-compile ng isang set of exercises. So I'll just put there some differential equations. I won't tell you what's the best way to solve them para matutunan yung mag-discriminate o mag-distinguish. Pag meron akong isang ODE na ganito yung itsura, ano kaya yung pinakamadaling solution na gagamitin? Kasi hindi mutually exclusive yung mga techniques na natutunan natin sa section 2. More than one method can be applicable to an ODE. So kayo na yung bahala pag hindi kayo sinabihan na humanap ka ng integrating factor o gamitin mo yung technique para sa exact differential equations para sa ODE na to. So chances are sa exam, hindi namin sasabihin sa inyo kung anong method yung gagawin. Kayo yung bahalang tumingin. And sometimes yun yung mahirap o yun yung nagpapatagal kasi kailangan mo pa mag-decide anong method yung gagamitin ko para ma-solve itong ODE na ito. Alright? So kaya yun ang gagawin ko. Sa reading break, check niyo yung Canvas every now and then. Siguro, okay lang ba na mag-email ako sa inyo pag na-upload ko na yung practice problem set para sa midterm exam? So bubulabugin ko ng konti yung inyong reading break. Hindi naman required, ano? Hindi ko ipapasubmit. I'll just upload a set of exercises, a bunch of DEs, or some questions na pwede niyong pag-practicean in preparation for the midterm exam. Okay lang ba yun? So expect an email during the reading break. Huwag niyo akong dedemanda ha kapag or huwag niyo akong irereklamo sa OVCAA. So it's just an optional thing for you to access para makapag-prepare kayo for the midterm exam. Okay? But enough of the chit-chat. So diretso na tayo sa section 3.2 to 3.3 because I know all of us are waiting to throw out our phones, our notes para makapagpahinga muna for the reading break. So let's get going. We're still in chapter 3 where we try to develop a theory on how to solve general linear differential equations. Kasi parang sa chapter 1 natali tayo, sa chapter 2 natali tayo sa mga first order linear differential equations. Ngayon, i-build up natin yung theory paano mag-solve ng mga linear differential equations that involves higher order derivatives. And we started talking about it last meeting when we talked about section 3.1 na pinakilala ko kayo dun sa iba't ibang klase ng GLDEs. Ngayon, titingnan natin ano yung blueprint para sa pag-solve ng mga GLDE. So hindi pa tayo mag-solve ng specific GLDEs, titingnan muna natin paano tayo nakakakuha ng solution o ano yung itsura ng mga solution ng mga general linear differential equation. And then the actual solving of these GLDEs will be explored in the next sections. So titingnan muna natin ano yung blueprint, ano yung template sa mga solutions sa mga GLDEs. All right. Now, first, we need to talk about a concept from linear algebra. Can I see a show of hands? Sino na rito yung tapos mag-math 120 or AMAT 105? Linear algebra or matrix theory? I forgot anong title ng 105, ng AMAT 105. So, tapos na ba kayo? Raise your hand kung tapos na ng 120 or 105. Okay. So, yung iba ay wala pa or currently taking it. That's fine. I'll try to be as specific as possible, or as detailed as possible. Kasi may mga concepts dito. Actually, kahit sa mga susunod na chapter, kailangan yung mga linear algebra techniques. So, if something is not familiar to you, just call my attention. Baka kasi at the back of of my mind, you already took linear algebra. Meron akong pasadahan na term na sa linear algebra nyo pa mamimit or sa matrix theory nyo pa mamimit. Pagka ganon, nakalimut ako na meron pa mga hindi nakakapag 120 or 105, just let me know, all right? Para i-explain ko in details yung particular concept na yon. Okay? Now, the first concept, which is from linear algebra, ito nga linear independence. Kapag ka meron kang set of objects, kailan natin sinasabi na sila ay linearly independent? Or kung hindi sila linearly independent, ang tawag sa kanila ay linearly dependent. Okay? So, to know whether a set of objects is linearly independent or not, you just take a linear combination. So, ito yung tinatawag natin na linear combination ng mga objects na yon. So, dito ang kinuha natin ay linear combination ni F1 until Fn. Yung objects of interest natin dito ay mga functions. So, ang tanong, kailan ang isang set ng functions ay linearly independent o linearly dependent? Okay? So, para malaman kung ito ay linearly dependent or independent, kumuha ka ng arbitrary linear combination. Ibig sabihin, you assign some constant multipliers to your objects, tapos i-add mo yung scalar multiples nila. So, constant times function 1 plus constant 2 times function 2 all the way up to constant n times function n. So, ito yung tinatawag natin na linear combination. So, tapos equate mo sa 0 yung linear combination na yon. And you look at what is the solution set of this equation with respect to the constant c sub I until c sub n. Kasi given sa simula yung F1 hanggang Fn, sila yung tinetest mo kung linearly independent ba sila or linearly dependent sila. Kumuha ko ng linear combination at inassume ko na 0 yung yung value ng linear combination na yon. Question is, what are the constants that will make the linear combination equal to 0? So we need to look at ano yung solution ng equation na to in terms of the n-tuple C1, C2 hanggang Cn. Alright? Kung merong nag-exist na isang set ng C1 to Cn na hindi silang lahat ay 0. Ibig sabihin, at least isa sa mga C sub n's ay hindi equal kay 0, then we say that the set of functions is linearly dependent. Linearly dependent siya kapag ito ay nagiging totoo for one set of constant C1 hanggang Cn na at least isa dun sa mga C sub i's ay hindi 0. Right? Ang tawag natin sa ganung solution ay non-trivial solution. Because the trivial solution, yung obvious solution, sa equation na to ay si C1, si C2, hanggang kay Cn, lahat sila ay 0, right? Kasi pag si C1, si C2, hanggang kay Cn, lahat ay 0, then obviously the equation is true. So we know that this equation has at least one solution. The solution of all zeros. Yung solution na lahat ay 0, ang tawag natin doon ay trivial solution. Pero, pag nakahanap tayo ng isang non-trivial solution, meaning we found a set of constants C1 until Cn, one of them, at least one of them is not equal to 0, then we say that we have a non-trivial solution, and so the functions are said to be linearly dependent. Okay? Bakit siya tinatawag na linear dependent? Kasi ibig sabihin kapag ka nakahanap ka ng at least isa sa mga constants na to ay non-zero, ibig sabihin yung at least isa sa mga f sub i's ay kaya mong isulat as a linear combination ng ibang mga f sub i's. Kaya siya linearly dependent kasi at least isa dun sa mga functions natin ay kaya nating isulat as a linear combination of the other functions. Pero kapag wala ng ibang solution kundi yung trivial solution, meaning if the only solution to this equation is the set of all c sub i's na lahat sila ay zero, yun yung pagkakataon na tinatawag natin na yung set of functions ay linearly independent. Alright? So it is linearly independent if we only have a trivial solution, all right, to this equation. Pag puro zeros lang, yung tanging paraan para maging totoo itong equation na to, yun yung tinatawag natin na linearly independent. Linearly independent yung mga functions kasi hindi natin kayang isulat yung kahit alin dun sa mga functions na given in terms of the other remaining functions. Kaya sila ay independent sila sa isa't isa. Yun yung dahilan kung bakit ang tawag ay linearly independent. But you will dig deeper into these terms kapag nag-linear algebra na kayo or nag-matrix theory na kayo. Medyo mahalaga kasi yung konsepto ng linear independence when you go to linear algebra. Okay? Pero for us, just scratching off the surface, pwede nyo isipin linearly independent, magkakahiwalay o hindi related yung mga solutions sa isa't isa. Pag sinabing linearly dependent yung mga functions, ibig sabihin magkakamag-anak yung mga functions na yon. All right? And our interest would be for those linearly independent functions. Because kapag linearly dependent sila, magkakamag-anak sila, so hindi ko na i-consider lahat ng mga magkakamag-anak. So ibig sabihin kung lahat sila ay magkakamag-anak, pipili lang ako ng isang representative mula dun sa pamilya na yon. Kasi ang gusto kong makuha ay mga functions na hindi magkakamag-anak at all. Yun yung tinatawag natin na linearly independent solutions. Alright? Now, okay. Ang dami pa niya sinabi. Okay, quick example. F1 is the constant function 1. F2 is the linear function x. Sige nga, hula. Sino yung sa tingin nila ay ito ay linearly independent? Siguro sa chat na lang ano. So, what do you think about the relationship between F1 and F2? Are they linearly dependent or linearly independent? So in the chat, type LD if you think they are linearly dependent, type LI if you think they are linearly independent. No cheating, walang titingin dun sa notes, hula lang. Ano? So tanong, magkamag-anak ba si 1 at saka si X in terms of linear independence? Sige nga, I'll wait for your answers on the chat. Oh, hula lang. Wala namang minus to kapag kung mali yung sagot. Ano? Mabagal lang bang internet ko or nag-iisip pa kayo? Okay, wala nang habol? Okay, so parang okay, merong isang linearly dependent, tapos halos lahat ay linearly independent na. Okay, let's see. So, I mentioned earlier na yung interpretation ng linear dependence or linear independence ay kung kaya mo bang i-express yung isang function as a linear combination of the other functions. Alright? So pag tinignan mo tong 1 at saka si x, si 1 ba kaya nating isulat as a linear combination of x? So meaning, is there a constant multiplier to x that will give us 1? Alright? Or the other way around. Can we write x as a linear combination of 1? Can we write x in terms of a constant times 1? Yun yung parang tanong sa linear independence or linear dependence. Okay? Magkamag-anak ba si 1 at saka si x? Can I write one of them as a linear combination of the other? Okay? And now, I guess those who said linear independence has a good instinct with respect to this problem because these two guys are not related at all via linear combinations. Kaya sila linearly independent. Kasi si x, hindi ko siya kayang isulat as a constant times 1. And it's also true the other way around. I cannot write 1 as a linear combination of x or a scalar multiple of x. Pero if you have doubts or if you cannot see it right away, then punta tayo sa analytic argument. So if ang klase ng intelligence na meron kayo ay analytic, so sige, solve tayo. Paano natin chine-check yung linear independence? Kunin mo yung linear combination ng dalawang functions. Tapos equate mo siya sa 0. Tingnan mo kung meron kang non-trivial solution. Are there non-zero constants C1 and C2 such that this is true? Kapag nakahanap ka ng non-trivial solution, then they are linearly dependent. Kapag ka 0, 0 lamang yung solution, sila ay linearly independent. Okay? Now, set up the linear combination, equate it to 0, and then let's simplify. All right? So, si F1 ay 1. So, si 1 na lang yung matitira sa first term. Si F2 siya ay si X. So, siya yung nandun. So, we're solving this. When can this, oops, spoiler. Huwag niyo munang isipin yan. Okay, so kailan totoo itong equation na to, itong C1 plus C2x equals 0? Well, parang nagano ka rito, nag-equate ka ng polynomial sa 0. Kailan to magiging totoo in terms of the C1 and C2s? Well, una, ang constant term dito, pwede ko itong isulat si 0, pwede ko siyang isulat as 0 plus 0x. Right? And then, para maging equal, yung left side sa right side, dapat equal yung corresponding numerical coefficients. Alright? Ang numerical coefficient ni x dito ay C2. Numerical coefficients dito ni x ay 0. So that means C2 must be equal to 0. Alright? And if C2 is equal to 0, C2 is necessarily equal to 0, right? Kasi pag si C2 ay hindi naging 0, hindi na magiging totoo yung equation na to. Alright? So that means C2 is necessarily 0. 0 times x is 0. C1 plus 0 is C1. C1 equals 0, meaning pareha si C1 at si C2 ay dapat maging equal kay 0. Okay? Because if either one of them is non-zero, then we cannot get the 0 as the linear combination. All right? So, ibig sabihin, unique yung solution. Nag-iisa lamang yung solution sa equation na to, and that is the trivial solution. All right? Meaning dahil trivial solution lang yung meron tayo, ibig sabihin linearly independent si 1 at saka si x. All right? So there are several ways how to solve this equation. Sabi nung handout, though ayoko ng ganitong solution kaya ako binura. Pero this is another way to get the solution. You differentiate both sides, right? So pag differentiate mo sila both sides yung equation, makukuha mo ay C2 equals 0. Kuha mo na kagad yung isang part ng equation. Tapos kapag ka si C2 ay 0, katulad ng argument ko kanina, si C1 dapat maging equal rin kay 0. Okay? So kaya sila ay linearly independent. Ibig sabihin si 1 at saka si x ay hindi magkamag-anak in terms of linear algebra. All right? They are from two completely different families. Okay? So let's see another example. Sige nga. Kulang pa ito ng isa. Yan. X e to the x e to the x plus 2 minus 3x times e to the x. Are these linearly independent or linearly dependent? Type Li or LD respectively on the chat. Sige nga. Tingnan ko yung mga hula niyo. Number 2. Sige. Mabagal nga yung chat ko. Kaya late ko nakikita yung mga sagot niyo. All right. Let's see. LD, 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 Li. Okay. All right. I think these functions are linearly dependent. Okay. Mas maraming sumagot ng linearly dependent. Ano ba yan? Meron bang basihan yung mga hula nyo? Kaya ano yung giveaway? Bakit nyo nakita kagad na linearly dependent sila? Kasi kung ako, hindi ko yan makikita kung linearly dependent or independent sila kagad. So, ano ba yan? May basihan ba yung sagot nyo na LD or hula lang? Kasi hindi ako magaling sa mga ganyan eh. Kaya hindi ako pang quiz contest eh. Kaya hindi ko nakikita yung mga shortcuts, ano? Or hula lang yung LD. Magaling lang yung hula nyo. Ayaw niyong spill yung dahilan. Okay, so let's see. Why are they linearly dependent? Yeah, tama yung sabi ni Victor. Scalar yung isa sa kanila ay kaya kong isulat as a sum of the scalar multiples of the other. Alright? So ibig sabihin, meron ditong at least dalawa na magkamag-anak. Meaning meron diyang isa na pwede kong isulat as a linear combination of some of the other guys. Okay? Or pwede namang analytic argument. Balikan natin, kailan nga ba nagiging linearly independent ang isang set? So, if-form natin yung linear combination. Magkakaroon ako ng C1 times X plus C2 times F2, which is e to the power X, plus C3 X e to the X, plus C4 2 minus 3X e to the power X, and equate it to 0. Now the question is, do we have a non-trivial set C1, C2, C3, C4 that will make this equation true? Yun yung hinahanap natin, ano? Meron ka bang mga scalars? Meron ka bang mga constant real numbers that will make this equation true? Okay? Kailangan mag-zero sila. Well, sir, unang-una po, ano ba yung mga meron tayo rito? Lahat po ito ay may e to the power x. So baka naman, paano ko ba ito maka-cancel? Well, sir, tingnan mo to. Meron ka ditong 2 times e to the x. Tapos meron ka ditong e to the x. So baka pwedeng gawin ko tong 1. Okay? Hindi naman natin kailangan mahanap lahat ng solution. Kailangan ko lang makita meron bang solution. Right? That's the only question. Do we have a non-trivial solution? So pwede ako mag-isip, okay, gawin ko tong 1. For instance, gawin ko muna siyang 1. Kasi ang hulaan nyo dito, linearly dependent, no? So dapat meron akong makuhang non-trivial solution. At least isang non-trivial solution. So I can do it this way, hula-hula, trial and error. So halimbawa si C4 gawin ko 1. Kung ito ay 1, magkakaroon ako ng 2 times e to the x. Gusto ko mag-0, so dapat wala yung 2e to the x. Pero meron ako ditong e to the 2x. So pwedeng yung C2, palitan ko ng negative 2. Para ito, magkakaroon ako ng negative 2x. Pag inad ko yan dun sa positive 2 times e to the x, magzi-0 sila. Alright? So ibig sabihin, I have taken care of ito at saka ito. Tanggal na sila, right? So malapit na ako na mapa-zero ko ito. Tapos, tingnan ano pa yung natitira dito sa huli. Kasi ito yung pinaka-komplikado eh. Ito yung gusto kong ma-cancel. So magkakaroon ako ng 1 times negative 3x times e to the x. Meron ako natitira dito na negative 3x e to the x. Meron akong x e to the x dito. So pag ginawa kong 3, yung coefficient niya, maka-cancel ko yung nasa fourth term, right? So that means I can make it positive 3, and this guy will cancel the remainder of the fourth term, right? Tapos ano lang natitira? C1 x equals 0. Well, I can choose C1 to be equal to 0. All right? Now, our C1 is 0, our C2 is negative 2, our C3 is 3, and our C4 is 1. It's a non-trivial solution, and yet the linear combination is equal to 0. So that means we have found at least one non-trivial solution. So ibig sabihin, etong family na to ay linearly dependent. Okay? So congratulations dun sa mga nakahula. Alright? Kasi kaya kong mapa-zero yung linear combination without using the trivial solution. Alright? Is that clear? Any questions? Of course, hindi ganito laging kadali yung pag-check ng linear dependence or linear independence. Nagkataon lang na maganda yung itsura ni F1 at saka ni F4. Madaling ma-distinguish na meron sa kanilang magkakamag-anak. Right? So in that sense, magkamag-anak, hindi pala magkamag-anak, parang offspring ni e to the x at ni x e to the negative x, ni F2 at saka ni F3 si F4. Kasi kaya kong makuha si F4 or masulat si F4 as a linear combination of F2 and F3. that makes F4 linearly dependent on F2 and F3 because F4 can be written as a linear combination ni F2 at saka ni F3. So, ibig sabihin si F4, kamag-anak siya ni F2 at saka ni F3. Alright? Kahit si F2 at saka si F3 ay hindi magkamag-anak, pero kamag-anak nila, so pwedeng by marriage, lakas maka House of the Dragon eh. So, nasa lineage ni F2 at ni F3 si F4. Okay, kaya sila linearly dependent. So, later, when we try to write our solution, hindi ko na isasama si F4 pagsusulat ng solution ng isang ODE. Kasi kamag-anak naman to ni F2 at saka ni F3. So dito na lang magfo-focus sa dalawa na to. Because anyway, I can derive F4 in terms of a linear combination of F2 and F3. Okay? All right, any questions so far? Okay, so kung wala naman, let's move forward. Okay. Sabi ko nga, hindi ganun kadali. Hindi ganun laging kadali na maghanap or mag-check ng linear independence. So, at least for Math 151, we'll use a very important tool in terms of ODEs. Yun yung tinatawag natin na Wronskian. Alright? So, the Wronskian of a set of functions f1 to fn, which are differentiable at least n minus 1 times, ay given by this determinant. Okay? So, kailangan nating computein yung determinant ng matrix na ang laman ay, ang first row ay f1 until fn, second row ay mga first derivatives nila, third row ay mga second derivative nila, fourth row ay mga third derivative nila, and the nth row of the matrix we're considering ay yung mga n minus 1 derivative nila. That's why kailangan yung mga functions natin ay at least n minus 1 times differentiable. Then you form the matrix, then you take the determinant of that matrix, then you get the Wronskian. So at yung value nito, the scalar value of this guy, hindi pala scalar, pwede kasi siyang function eh. Basta yung sagot dito sa determinant na yan, siya yung tinatawag natin na Wronskian ng function. So for those who haven't taken 120 or 105 yet, or kung hindi nyo pa nadidiscuss doon, ang isang matrix ay isa lang rectangular arrangement of objects. So dito, in-arrange lang natin into rows and columns yung mga given functions at saka yung mga derivatives nila. The determinant is a number that we assign, a number or a function that we assign to the matrix na para maging representative ng matrix na yon. Maraming properties na nakukuha mula sa determinant. Now, if you're taking the determinant of this particular matrix, the matrix form with the rows corresponding to some order derivatives of the functions given, makukuha natin yung Wronskian. At makikita natin mamaya yung Wronskian, kaya niya sa ating sabihin kung linearly dependent or independent ba yung F1 hanggang kay Fn. Okay? Paano mag-compute ng determinant? Siguro idadaan ko na lang siya sa examples. Kasi yung definition ng determinant, it's about odd and even permutations of the entries in the matrix. So yung mga nagwa 120 or 105, alam nila yung definition na yan or na-encounter nila. Or there's a more abstract definition to it. The determinant function is just a function that satisfies certain conditions. Pero for us, computational lang naman yung treatment natin sa determinant. So sasabihin ko na lang or tuturo ko na lang kung paano mag-compute ng determinant. Basta pag pinag-compute ko kayo ng Wronskian, which is important because this is part of the objectives for the chapter. So pag-compute ng Wronskian, nagsisimula by making a rectangular arrangement of functions. Ang unang row, yung given functions. Second row, yung mga first derivatives. Third row, second derivatives, hanggang makarating ka sa n minus 1 derivative. Tapos saka tayo magko-compute ng determinant. Okay? So let me just show you how to compute the Wronskian. So balikan natin yung 1 at saka yung x. Alam natin sila ay linearly independent. Okay? Kasi madaling isolve yung linear combination equal to 0. Pero daanin natin sa Wronskian. So ang Wronskian ng f1 at f2 na to is a function of x. So posibleng may variable x yung sagot niyo sa Wronskian. And this Wronskian ay determinant. So maglagay lang kayo ng parang absolute value bar dyan. Tapos gumawa kayo ng rectangular arrangement ng mga functions. The first row of which would be f1 and f2. So f1 and f2. Tapos yung second row ay yung mga first derivatives nung f1 and f2. So derivative of 1 is 0. So siya yung directly below 1. Tapos derivative ni x ay 1. Okay? And then kapag ka 2 by 2 yung matrix, so pag meron kang 2 rows and 2 columns in your rectangular arrangement, ang determinant ay product pababa minus product pataas. Alright? So this is gonna be 1 times 1, the product pababa. So that's 1 minus the product pataas. 0 times x is 0. And this is equal to 1. So the Wronskian of f1 and f2 is equal to 1. Okay? And take note, 1 yan. Alam natin, linearly independent si f1 at saka si f2. So take note, linearly independent ito. Itong example na to, ang Wronskian niya ay 1. Tapos sabi ni Sir kanina, yung Wronskian, kayang sabihin sa atin kung linearly independent or hindi. So try to put that at the back of your mind para mamaya makagawa tayo ng hypothesis. Ano? So ang Wronskian niya ay 1, tapos alam ko to ay linearly independent. We are investigating ano yung relationship ng Wronskian dun sa linear dependence or linear independence. Okay? So is that good? Naalala na ba paano mag-compute ng determinant ng 2 by 2? Okay, mag-alala. Papunta pa lang tayo sa exciting part. Ano? Medyo trivial yung pagko-compute ng determinant ng 2 by 2 kasi product pababa minus product pataas lang yan. Alright? Ang mahirap kapag ka marami na, pag malaki na yung matrix. Okay? I hope this is good, especially for those who haven't encountered determinants and matrices before. Okay? Now, let's see a more exciting example. 1x at saka x squared. Okay? Tingnan natin kung ito ay kung ano yung Wronskian ng tatlong functions na to. Well, again, the Wronskian is the is the determinant of kasi tatlo yung function, so dapat magkaroon tayo ng 3 by 3. Alright, tatlo yung function, so dapat 3 by 3 yung aking rectangular array o yung aking matrix, right? The first row, copyahin ko lang si F1, si F2, at saka si F3. Tapos yung second row, mga derivatives nila. 0, 1, 2x. And then yung third row ay what? Yung third row ay magiging derivatives ng second row, right? Kasi dapat ito ay second derivative ni F1, F2, and F3. So I'm going to differentiate this row to get the entries in the next row. So this will be 0, this will be 0, this will be 2. Okay, paano nagko-compute ng determinant ng 3 by 3 matrix? Sino nakakalala? Actually, there are two methods on how to do this. At least two methods. I don't know if you encountered them. Yung unang method ay tinatawag na basket weave. Kopyahin ko lang to. Basket weave kasi ang gagawin mo, gagawa ka ng parang basket. Maglalala tayo, mag-weave tayo. So you duplicate yung first two columns. Alright? Nag-work lang to sa 3 by 3. So 1, 0, 0, x, 1, 0. So, dinuplicate ko lang yung first two columns. Tapos, kukunin ko yung mga product pababa. Mga product pababa, 1 times 1 times 2. So, we get 2 plus product pababa, 0 plus product pababa, 0 minus product pataas. 0 times 1 times x squared, that's 0. 0 times 2x times 1, that's 0. 2 times 0 times x, that's 0. Okay? Kaya ang tawag sa kanya basket weave kasi parang nakapagawa raw ako ng basket dito. Naglala ako na pattern pababa, pattern pataas. Alright? And the answer here is 2. Okay? Ayan yung Wronskian netong set na to. And what do you think about these three functions? Are they linearly independent or linearly dependent? What do you think? Linearly independent, sabi ni Kian. Yeah, yun din yung conclusion ni Kiefer, ni Rensis, ni Reynolds at ni Zai. Yes, these three functions are linearly independent. Kasi nga madali lang, no? Kasi C1 times 1 plus C2 times x plus C3 times x squared equals siya dapat kay 0. Pero si 0 ay kaya kong isulat as 0 times x plus 0 times x squared. And this is the only way I can write 0 in terms of the polynomials x squared, and constant, right? So ibig sabihin, si C1 ay 0, si C2 dapat ay 0, at si C3 ay equal kay 0. Kasi pag may isa sa kanila na hindi nag-0, automatic non-zero na yung polynomial ko, right? Kaya madali makita na itong family na to ay linearly independent. Tapos linearly independent to, tapos yung Wronskian niya ay 2. Kanina si 1 at saka si x, linearly independent sila, tapos yung Wronskian nila ay 1. Perhaps there's something there. So, kasi explore natin yung relationship nila. Okay, now there's another way on how to solve the determinant. Kasi itong Wronskian naman ay pagko-compute lamang ng determinant. Pag once na-arrange mo na yung matrix, linear algebra na lang pagko-compute ng determinant. Well, may isa pang paraan ng pagko-compute ng determinant, and this is usually more general than the basket weave method. Kasi yung basket weave method, applicable lang siya sa 2x2 saka sa 3x3. Yung 2x2, product pababa minus product pataas lang, you get a mini basket. Tapos kapag ka 3x3, ito na yung mas mukhang basket. Pero, in general, hindi sila mag-work. Ang ginagamit natin ay yung tinatawag natin na cofactor expansion. Okay. Ano yung cofactor expansion? So, ang ginagawa natin dito ay pumipili ako ng row o kaya column kung saan magpipivot. Alright? Usually, pinipili yung row or column kung saan ka mag-expand ay yung maraming zero. Kasi makikita nyo mamaya kung bakit gusto ko maraming zero. Well, dito, yung first column, yung maraming zeros. So I will pivot my cofactor expansion along the first column. Okay? So paano ginagawa yung cofactor expansion? Ang gagawin natin, so highlight ko lang to. Dito ako magpipivot. Alright? Now, ang mangyayari rito ay, sa cofactor expansion, pinapaliit natin yung kinukunan natin ng determinant. How so? Ganito. Yung unang entry ng pivot row or column, i-take note mo siya. So, magkakaroon ka ng 1 times negative 1. So, ito, kukopyahin ko lang siya dyan. 1. Tapos, i-multiply ko siya ng negative 1 raised to the I plus j, where I is the row number and j is the column number. So, si 1, saan siya naninirahan? Si 1 ay naninirahan sa first row, first column. So, I is 1, j is 1. So, I'll have 1 plus 1 as a multiplier, as a power to negative 1. Kasi kailangan ko ma-determine ano yung sign niya. Positive 1 ba o negative 1? Okay? Ang nagde-determine ay yung sum ng kanyang row number at saka column number. And then times yung minor. Yung determinant ng minor. Ano yung minor? Tatakpan mo lamang ito at saka ito. Binubura mo yung pivot column, tapos tinatakloban natin yung pivot row corresponding to the element na kinonsider natin dito. So matitira na lang ay determinant ng 1, 2x, 0, 2. So 1, 2x, 0, 2. Right. And then I'll do this for all of the rows in my pivot column. Plus, dito naman ako, second entry na ako. Second cofactor na ako. So dito ako nagpipivot, tapos na ako kay 1, so kay 0 na ako. Kopyahin ko si 0 doon. So 0. Kaya gusto ko nagpipivot dun sa maraming 0. Kasi yung elements ng pivot row or column, sila yung nagiging multiplier dun sa harap. Pero just for the sake of exposition, i-expand ko pa rin to. Alright? Pero alam niyo na mangyayari, kahit ano pa yung multiplier dito, ang sagot ay 0 for the second term. Kasi meron na ako multiplier na 0. Tapos kailangan ko i-determine yung sign. Negative 1 raised to the, I am on the second row, alright, okay, second row, first column. So there should be a 2 plus 1. Pero in general, nag-ano lang naman yan, nag-alternating sign. Ito ay positive 1, ito ay negative 1. You can guess that the third cofactor will have a positive 1. kasi nag-alternating sign lang yan. Pero sinusulat ko to para alam nyo in general. Ano yung nangyayari? It's -1 raised to the row plus column number. Okay? Times determinant nung minor. Aling minor? Yung minor na ma-obtain kapag binura mo yung pivot column at saka yung row corresponding to the pivot element. Dito tayo nagpipivot sa 0, so buburahin ko yung ka-row ni 0, buburahin ko yung column ng pivot, so matitira na lang ay x squared 0, 2. X squared 0, 2. Ito yung kukunan ko ng determinant. And then lastly, third row na, tapos na ako dito, so dito na ako magpipivot sa 0 na to. Tapos this would be -1. Etong pivot element natin na kinopya ko doon, naninirahan sa third row first column. So I'll have 3 plus 1 in the exponent here times the determinant of the minor. Ano yung minor? Takpan yung first column, takpan yung third row, matitira ay si x squared 1, 2x. Okay? Tapos, computein mo na to. 2 by 2 na to, no? So madali nang computein yung determinant ng 2 by 2. But actually, I need not compute for these two terms kasi kahit ano pa yung determinant na to at saka ito, naka-multiply naman sila by 0. Kaya masaya na mag-cofactor along dun sa row or column na maraming zeros. Kasi yung pivot element, multiplier siya dun sa harap. So ito mawawala, ito mawawala. So ito na lang talaga yung kailangan kong computein. Alright? Now, what is this determinant? Well, 2 by 2 na lang yung determinant na to. So, product pa ba is 2. Product pataas ay 0. So, here I'll get 2. I'll have 1. And this is also 1. 1 times 1 times 2. The determinant is equal to 2. Okay? So, that's the cofactor expansion. Ang maganda sa cofactor expansion, magagawa nyo to or magagamit nyo to kahit ano yung dimension ng matrix. Kaya lang ang problema pag malaki na, no? Pag halimbawa 4x4 yung matrix, sa isang row or column ka magpipivot, so makakuha ka rito ng summation ng mga determinants ng 3x3. Pero kung ito ay 3x3, pwede ka uling mag-cofactor expansion. Tama rin si Victor. Nice catch, Victor. Kasi sa linear algebra, meron theorem na kapag ka upper o kaya lower triangular yung matrix, ang determinant niya ay product ng diagonal entries. Tama nga ba? Tama na, Victor, yun yung theorem sa linear algebra. So, dahil ito ay upper triangular, ibig sabihin, sa ilalim ng main diagonal, puro zeros yung entry. Okay? May theorem sa linear algebra na ang determinant nito ay 1 times 1 times 2 lamang. Alright? Good catch, Victor. Pero ayokong gamitin yon kasi hindi lahat ay nakapag-linear algebra. Pero kung gagamitin nyo to sa exam o kaya sa homework, pwede nyo sabihin nyo lang na by a theorem in linear algebra. Okay? Or pwede nyo sabihin na since the determinant of a lower triangular matrix is just the product of the diagonal entries, then the determinant or the Wronskian is equal to 2. Pwede rin naman ganon. Pero pagka nagsosolve kayo, sabihin nyo yung reason. Okay? Para alam ko yung ano yung ginamit nyo na reasoning. But I don't expect everybody to know that theorem. Okay? Kaya dadaan sa cofactor expansion. Pero you're right, Victor. Pwede yung gamitin yun. Okay? So, other questions? Is this clear? Pero again, disclaimer, yung suggestion ni Victor, nag-work lang siya kapag ka upper o kaya lower triangular yung matrix. Upper triangular ito kasi yung lower triangle, ang laman niya ay puro zeros. Yung nasa ilalim ng main diagonal, puro zeros. Pero nag-work din yun sa lower triangular. Kung yung mga zeros naman ay nandito, ito yung main diagonal, tas nandito yung non-zero entries. Okay din naman yun. Nag-work din yung theorem na yun. Or kung diagonal yung matrix, ibig sabihin diagonal entries ay mga real numbers tapos 0 siya sa taas, 0 sa baba. Nag-work din yung theorem ni Victor. Alright? Other questions, clarifications? Wala pa naman so far? Okay, good. So, okay. All right, let's try this one. The Wronskian, find the Wronskian of these functions. Ito yung apat. Ang alam natin dito sa apat na to, napakita na natin na sila ay linearly dependent. Tingnan natin ano yung itsura ng Wronskian niya. Well, if you form the Wronskian, ito yung makukuha natin. Unang row ay si F1 hanggang kay F4 lamang. Tapos, susunod na row ay derivative. So, differentiate si x, makukuha may 1. Derivative ng e to the x ay e to the x. Derivative ng x e to the x, kailangan nyo ng mag-product rule. So, you will get this guy. Dito, kailangan nyo rin ng product rule. So, eto na, product rule. Tapos, susunod na row ay derivative ng second row. Derivative ni 1 ay 0. Derivative ni e to the x ay e to the x. Derivative nito ay masisimplify nyo dito using the product and the addition rules. Tapos ganun din yung nandito. And so on. Hanggang makakuha ka ng 4x4. Meron kang apat na functions. So ibig sabihin 4x4 dapat yung matrix mo. Okay? Or hanggang n-1. So hanggang third derivative dapat yung ginamit mo para mabuo yung matrix na kukunan natin ng determinant. Now, if you try cofactor expansion, you will expand along the first row. Along the first column. Kasi dito lang maraming zeros. Kaya lang ang problema, halimbawa, pag mag-expand na ako sa first column, nandun ako sa pivot, unang pivot, ano? So magkakaroon ako ng x times -1 to the second power. Tapos determinant nung buburahin ko to, oops, 3/3 yung lalabas. Alright. Magko-cofactor uli ako para makuha yung 3/3 na yun. So mahaba yung proseso. Ano? Pero this can easily be seen to be equal to 0. Pwede nitong pag-practicean later ng cofactor expansion, pero hindi ko na siya ipapakita kasi medyo mahaba. Pero equal to kay 0. Paano ko siya nalaman na 0? Well, gumamit ako ng isang theorem sa linear algebra para ma-forgo yung mahabang computation. But again, if you're patient enough, you can use cofactor expansion, preferably along the first column, to get the determinant. Pero yun nga, dun pa lang sa first expansion, kailangan mo na mag-determinant ulit ng 3/3. Magko-cofactor expansion ka na naman dito. Pero meron kasing theorem sa linear algebra na kapag yung isang column ay linear combination ng iba pang mga column, then you will get a 0 determinant. Okay? So kung kaya mo ipakita na yung isang column ay linear combination nung ibang mga column, then siya ay linearly yung determinant ay magiging equal kay 0. All right? So here you will see that the fourth column, all right, yung fourth column ay linear combination lamang nung second at saka third column. We simply need to multiply the second column by 2, the third column by 3, and then you will get the fourth column, right? So you'll get 2 times e to the x, -3 pala to dapat. So so 2e to the x minus 3x e to the x. Oy, yun yung fourth entry sa fourth column. Then tingnan nyo yung second row. 2 times e to the x minus 3x e to the x plus -3e to the x. That will simplify to this guy, right? 2 times this plus -3 times this will be equal to this guy. And similarly for the fourth row. Ibig sabihin, yung fourth column ay linear combination lamang nung second at saka third column. Meron theorem sa linear algebra na nagsasabi na kapag yung isang column ay linear combination ng dalawa pang ibang column or more, ang determinant automatically becomes 0. Okay? Kaya alam ko to ay equal kay 0 kagad. Pero don't worry, I don't expect you to know that theorem. Alright? Ginamit ko lang siyang palusot para hindi ko kukomputin yung determinant dito. Alright? So, kung hindi nyo alam yung theorem na yon, magko-cofactor expansion ka. But eventually, you can show that this is equal to 0. Okay? Now, don't worry, hindi kayo ni-expect na alam niyo yon sa exam. Alright? So, madadaling cofactor expansion lang yung ibibigay sa exam. Now, going back here, So, ang Wronskian ay 0, pero ano alam natin dito? Linearly dependent. Yung apat na yan. And the Wronskian is equal to 0. And as I mentioned earlier, the Wronskian is a nice test for linear independence. So based on the three specific examples that we have, what hypothesis can you draw about the relationship between the Wronskian and linear independence? Sige nga. Kanina, dun sa mga linearly independent set of functions, ang Wronskian natin ay 1 at saka 2. Pero dito sa linearly dependent, ang Wronskian natin ay 0. So based on that, what is your hypothesis? What do you think is the relationship between the Wronskian and linear dependence or linear independence? Tapos itetest natin kung totoo yung hypothesis nyo or hindi. Hula, hula. Okay, sabi ni Reynold, if Wronskian is greater than 0, then the functions are linearly independent. Yeah, you're partly correct. Si Rensis naman, if Wronskian is 0, linear dependence, otherwise linear independence. Almost correct, partly correct. Kiefer, so kay Rensis yun. Kay Kiefer naman, determinant is degree ng highest degree. I'm not sure about that, pero we can take a look at it. Pero hindi yun yung hinahanap ko, Kiefer. But nice try though. Si Kian Keef naman, kapag ka ang determinant ay positive, linear independence. Kapag ka ang determinant ay 0, linearly dependent. Partly correct, all right? Now, one thing about determinant. Ang determinant, ang determinant, although ang gamit nating symbol ay absolute value bars, ang determinant ay hindi laging positive. So pwedeng maging negative yung determinant. All right? So be careful with that. Pwedeng maging negative yung determinant. Okay? Now, almost correct yung sinabi nung majority ng mga nanghula o yung mga hypothesis ninyo na kapag ka 0 yung Wronskian, linearly dependent. Tapos pag hindi 0, linearly independent. Kaya yung mga nagsabi na kapag ka yung Wronskian ay greater than 0, siya ay linearly independent, you're just partly correct. Kasi kapag ka posible na maging less than 0 yung Wronskian. Alright? Pero ito yung totoo. So medyo partly correct yung mga nasa chat. Pero this is the theorem. Alright? So yung functions f1 hanggang fn ay linearly independent on a given interval if and only if the Wronskian is not 0 for at least one value of x in the interval. Ito yung kulang dun sa mga hypothesis na nasa chat. Ano? So kasi yung Wronskian, remember yung Wronskian ay function ni x. Nagkataon nga lamang na yung mga examples ko ngayon, puro constant yung sagot dun sa determinant. Pero the Wronskian, dahil ang kinukunan natin ng determinant ay isang matrix na may mga variables. So yung Wronskian natin, posibleng magkaroon ng variable x. So yun yung ano. Kaya sinabi ko kanina, partly correct yung mga nasa chat. Kasi hindi natin na-take into account na posibleng magkaroon ng variable x dun sa determinant. Nagkataon lang na examples natin kanina, puro constant yung determinants. Pero the Wronskian can involve the variable x. And when the Wronskian is not 0 for at least one value of x in the interval, then the functions are linearly independent. So in summary, kapag ka yung Wronskian ay laging 0 sa lahat ng x doon sa given interval, then the set of functions ay linearly dependent on that interval. However, if the Wronskian is sometimes not equal to 0 in the given interval, then the given functions are linearly independent. Okay? So, ito yung nakita natin kanina. So, itong F1 at F2 natin, ang Wronskian niya equal kay 1. Never naman nagsi-0 yung 1. So, perfect candidate. So, sure tayo na sa kahit anong interval, linearly independent si 1 at saka si x. Second, ito ay laging 0. So, ibig sabihin sa kahit anong interval, si F1 hanggang si F4 ay laging linearly dependent. Kasi laging 0 yung Wronskian niya mapasaan pang interval. Okay? Is that clear? So, dun sa mga nag-174, meron tayong nakita sa 174 na family of sets, the Chebyshev polynomials and the Legendre polynomials. Ano? So, you can show via Wronskian na ang Chebyshev polynomials ay linearly independent sa interval -1 to 1. Kasi pagka kumuha ka ng first n Chebyshev polynomials, kinompute mo yung Wronskian ng Chebyshev polynomials na yon, yung makukuha mong determinant ay never magzi-zero, ay sometimes hindi zero sa interval -1 to 1. Kaya yung Chebyshev polynomials ay linearly independent sa interval -1 to 1 because their Wronskian is sometimes not equal to 0 on that closed interval. Ganon din yung Legendre polynomials. Ano? So dun sa mga hindi pa nag-174, mamimit nyo sila. Yung Chebyshev polynomials at saka yung Legendre polynomials. Okay? O maybe maganda palang ipa-exercise ko yun dito. No? Pakita na sila ay linearly independent talaga. Pero just a connection between 174, 151, and 120. All right? Now, as a practice, hanapan nyo nga ng Wronskian ito. Pero rito ay, pwede kayo mag-cofactor expansion kasi maraming zero yung first column, right? Kasi pag ginawa nyo yung ano nito, pag ginawa nyo yung matrix dito, magkakaroon ka lang ng 1, x squared, x cubed, x to the fourth, x to the fifth. Next row would be the derivatives. 0, 1, 2x, 3x squared, 4x cubed, 5x to the 6, tapos 0 ulit, 0, 2, 6x, 12x squared, 30x to the 4, to the what? Sorry, mali pala. Ito ay 4 lang. So 20x cubed lang, right? But eventually, you'll get an upper triangular matrix. So pwede nyo gamitin yung tinuro sa atin ni Victor na kapag ka upper triangular o kaya lower triangular yung matrix, product lang ng diagonal entries yung determinant. But if you forgot about that, then you can do the cofactor expansion to show na ito ay linearly independent. Kasi yung Wronskian nito ay constant, not equal to 0. Okay? So I'll just put that as a homework or, sorry, hindi homework, practice na lang. Kasi wag muna, relax muna kayo ng reading break. Ano? So hindi muna ako magpapa-homework over the reading break. Okay? But please try this one. Practice na rin pagko-cofactor expansion. Okay. Bago tayo pumunta sa section 3.3. Siguro let's take a 2-minute break before we go to 3.3. Ilang slides pa ba to? 16 slides pa. Sana matapos ko. So 2-minute break, guys. Or information overload na ba? Tapusin ko na lang yung 3.3 ano para sakto ano. Ano lang naman to, hindi to masyadong involved. So medyo magaan lang to. All right. So wala ko ng water, guys, and then I'll be back. Meron pa ba kayong mga klase after nito? Or last class nyo na to bago mag-party-party, bago mag-reading break? Fortunately, may klase pa ako mamaya. And it's quite a bummer kasi 5:30 to 7. Ano? Anyway, yeah, tapos na yung 2-minute break, so balik tayo. Now, this is section 3.3, and we'll be talking about how to get the general solution of a GLDE. All right? Tapos dito, kakailanganin natin yung konsepto ng linearly independent set. Kasi makita nyo later, para ma-capture yung general solution ng isang general linear differential equation, kailangan kong pagsamasamahin yung mga linearly independent solutions to that differential equation. All right? Now, but first, tingnan natin yung forma. Anong itsura ng solution, ng general solution ng isang homogeneous linear differential equation? Right? Now, homogeneous siya kasi 0 yung right-hand side ng GLDE. Right? So kapag ka meron kang order n na GLDE na homogeneous, ito yung itsura ng solutions niya. Okay? The solution will always be of the form linear combination siya ng n linearly independent solutions. Okay? So kung meron kang order n homogeneous differential equation, kailangan mo makahanap ng n na linearly independent solutions. Kasi ang usapan, pag pinahanap ko sa inyo yung general solution, dapat lahat ng solution dun sa ODE ay ma-represent natin or may sama natin dun sa representation ng solution. So we're looking for all the solutions to the GLDE. Kapag ka homogeneous yung linear differential equation, laging kailangan nyo maghanap ng n linearly independent solutions. Tapos yung general solution is any linear combination of those linearly independent solutions. Okay? Kaya mahalaga yung linear independence. Meron kang order n GLDE, kailangan mo ng n linearly independent solutions. Tapos yung general solution, yung final answer nyo ay linear combination ng mga linearly independent solutions. Kaya medyo mas challenging, hindi pala medyo mas challenging. Talagang mas challenging yung pag-solve ng GLDEs. The higher the order, the more solutions we need in order to get a general solution. Yung mga first order ODEs na sinolve natin sa section 2, first order lang sila. So ibig sabihin kailangan ko lang ng isang solution. Tapos magkakaroon lang siya ng constant multiplier. Kapag ka order n na, kailangan na natin ng n linearly independent solutions. And finding those n linearly independent solutions will be the subject of future sections. Pero ngayon, alam na natin yung template. Meron akong order n GLDE na homogeneous. Kailangan kong humanap ng n linearly independent solutions para ma-express ko yung general solution, which is basically a linear combination of the linearly independent solutions. Okay? Now, paano naman kapag ka non-homogeneous yung GLDE? So non-homogeneous ang isang ODE kapag ka yung right-hand side, yung forcing term ay hindi equal kay 0. Right? Now, kapag ka non-homogeneous yung equation, kailangan mong humanap ng isang particular solution. Isa lang. Hindi mo kailangan ng mga linear combination. Kumuha ka lang ng isang specific solution. And then, yung general solution netong non-homogeneous GLDE na to will be this. Ang general solution niya ay superposition ng general solution at saka ng particular solution. So, ito yung itsura niya. Okay? So, kukuha ka ng particular solution ng non-homogeneous. Alright? Tapos, kunin mo yung general solution ng homogeneous. Then, ang general solution ng equation 1 ay equal sa general solution ng homogeneous, tapos yung particular solution. Medyo mas mahirap mag-solve kapag ka non-homogeneous. Kasi kapag ka non-homogeneous, yung GLDE, kailangan mo munang humanap ng general solution dun sa homogeneous. Kita nyo yung two-step. So kapag ka given ka ng equation 1, given ka ng non-homogeneous GLDE, ang first step sa pag-solve sa kanya Isosolve mo muna yung homogeneous. Tapos alam nyo na, sa homogeneous GLDE, kailangan natin ng n linearly independent solutions. At yung linear combination ng mga linearly independent solutions na yon, sila si YC. O yun yung YC. Yun yung general solution. Tapos pag nakuha mo na yung general solution ng homogeneous GLDE, kailangan mo makahanap ng isang particular solution doon sa non-homogeneous. Kailangan mo ng isang specific solution doon sa non-homogeneous. Pag nakakuha ka na ng isang specific particular solution, then you can now draw up the general solution for the non-homogeneous GLDE. Ang general solution dun sa non-homogeneous GLDE ay yung general solution ng homogeneous plus particular solution nito. Okay? Now, it is easy to see that this is indeed a solution of equation 1. Bakit? Kasi pagka lahat ng derivatives dito, lahat ng y's dito, pinalitan ko ng yc plus yp, magiging equal kay r of x. Y kasi ito ay magiging YC plus YP. Ito ay magiging YC plus YP. Kasi ito ay magiging YC plus YP. Kasi ito ay YC plus YP. Tapos tingnan natin kung equal nga siya kay RX. Well, you can use the linearity of the derivative operator. So, pwede nyo itong paghiwalayan sa dalawa. Pwede mo itong isulat as a sub 0x times nth partial derivative ng YC plus a sub 0 times nth derivative ng YP all over dxn. Right? Tapos i-group mo yung terms, magkakaroon ka nito evaluated at YC at saka magkakaroon ka nito evaluated at YP. Tapos pag inad mo silang dalawa, makukuha mo ay Rx plus 0 magiging equal kay Rx. So what I'll do is try to prove that. So ang gagawin nyo lang naman, eto, nasimulan ko na siya. Pinalitan ko yung mga y's ng YC plus YP. Tapos expand nyo lang to, kolektahin nyo yung mga terms na may YC at saka yung may mga terms na YP. Pero ano ba si YC? General solution ng homogeneous. So yung derivative ng YC, yung terms na merong YC, magiging equal lang kay 0. Kasi si YC ay general solution ng homogeneous. Tapos ano ba si YP? Particular solution siya ng non-homogeneous. So essentially, magkakaroon ka ng 0 plus R of x equal to R of x. Alright? So hindi ko na siya ipapakita for lack of time, pero yun yung idea. Expand nyo lang to, makukuha nyo na si YC plus YP talaga ay solution ng non-homogeneous ODE. Alright? What I want to focus in this discussion is through the solutions. Pakita kung paano natin kinukuha yung solution ng isang non-homogeneous ODE or GLDE. Okay. So tingnan natin. It can be verified that e to the x and e to the negative x are linearly independent solutions of y double prime minus y. Well, how do we verify that this equation or these functions are solutions of y double prime minus y? Kailangan nyo lang palitan si y dito ng e to the x at saka ng e to the negative x, right? For instance, if y is equal to e to the x, y prime is e to the x, y double prime is e to the x, so yung y double prime minus y will be e to the x minus e to the x equal kay 0, boom. Solution siya talaga ng y double prime minus y equals 0. Right? Ganun din si y2 kasi kung y naman ay e to the minus x, ang y prime ay negative e to the negative x, si y double prime ay e to the negative x, so ibig sabihin yung y double prime minus y ay equal kay e to the negative x minus e to the negative x equal kay 0, boom. Solution siya uli ng ODE. Alright? So these two guys are indeed solutions of the given ODE. Alright? Tapos ano to? Second order. Sabi second order, so kailangan ko ng dalawang linearly independent solutions. Question, are these two guys linearly independent? Kasi kung linearly independent sila, So kukunin ko na lang yung linear combination nilang dalawa, then I get the general solution to the second order GLDE. All right? Now, how do we check linear independence? You can solve the linear combination equation equal to 0, and then see if you only have the trivial solution. Or better yet, use the Wronskian. All right? So ano yung Wronskian natin dito para sa dalawang functions? We have e to the x, e to the negative x. Second row will be the derivatives, e to the x, negative e to the negative x. All right? Kunin ko yung product pababa. I'll have negative e to the x plus negative x minus product pataas, e to the x plus negative x. This will be negative 1 minus 1 equal to 0, right? Because x plus negative x is 0, e to the 0 lang yan, negative 1 minus 1. Bakit equal to 0? Nagre-reading break na yung utak ko. So this is equal to negative 2. And negative 2 will never be 0 over any interval. So that means, since the Wronskian is non-zero, that means y1 and y2 are linearly independent. So we have two linearly independent solutions to the second order differential equation. So that means our general solution is a linear combination of these two guys. All right? But the good question is, how did we come up with y1 equals e to the x and e to the negative 2x? Well, that will be the subject of later discussions. All right? Pinapakita ko pa lang paano magbuo ng mga solutions dito. All right? Some more examples. Sorry, kailangan ko mag-overtime ng kaunti. Okay? So, it can be verified that these four guys are solutions of y to the fourth equals to 0, or fourth derivative of y equals 0. Madaling i-check kasi ang fourth derivative ng bawat isa sa kanila ay equal kay 0. So itong apat na yan ay may mga solutions nito. Fourth derivative equal to 0. Now, this is order 4, so we need 4 linearly independent solutions. So I have my fingers crossed, hoping that these guys are linearly independent. Well, paano natin i-check yung linear independence? I-check natin yung Wronskian. Alright? So I'll have 1, x squared, x cubed. Second row will be the derivatives. Third row will be the derivatives of the derivative, 0, 0, 2, 6x. And then fourth row will be the derivative of the third. And that's going to be our derivative. Now, you can do cofactor expansion along the first column kasi maraming zeros dyan. Or you can do cofactor expansion along the fourth row kasi marami ring zeros doon. Or you can use Victor's theorem. Sabi sa atin ni Victor kanina, sir, kapag ka upper triangular, product lang yan ng mga diagonal entries. Upper triangular to kasi sa ilalim ng main diagonal, puro zeros na yung entries. So mag-work yung theorem ni Victor. So ang determinant nito ay 1 times 1 times 2 times 6. Equal lang to kay 12, which is never equal to 0. So that means these four functions are linearly independent. We have an order 4 GLDE, so therefore the general solution to this GLDE is a linear combination of the four functions that we have. Okay? And it makes sense, right? Kasi alam natin na ang fourth derivative ng kahit na anong cubic function ay equal kay 0. Right? Kasi pag fourth derivative mo to, mauubusan ka na ng variable x. So essentially, ang third derivative nito ay constant, so yung fourth derivative niya magiging equal kay 0. And it makes sense, right? Any such cubic function, ang fourth derivative niya ay magiging equal kay 0. And this solution tells us na wala nang iba pa na ang fourth derivative ay laging equal kay 0 aside from cubic functions, right? Because here, this must be true for all x. Tanging mga cubic functions or polynomials of degree less than or equal to 3, yung may property na laging equal kay 0, yung fourth derivative nila kahit ano pa si x. Yun yung sinasabi ng statement na ito. Okay? Does that make sense? Any questions? Hingi pa ako ng konting minutes, guys. Probably 4 more minutes. Para lang matapos natin yung slides. 5 na lang naman yung slides. Right? Last example na to, promise. Okay? Questions? None? Alright. Now let's see. Paano naman nagbubuo ng solution sa isang non-homogeneous GLDE? Note that this is non-homogeneous because the forcing term, yung term na walang involved na y, ay non-zero. Meron tayong 4 minus 2x squared dito sa kanan. Okay. Ang first step ay, or actually interchangeable naman yung steps. Pwedeng una, humanap ka muna ng particular solution. Alright? Sabi rito sa slide, oh, particular solution yan ay 2x squared. Now, let's verify that. Pag ba si y pinaltan ko ng 2x squared, yung y double prime minus y ay equal ba kay 4 minus 2x squared? Let's see. If y is equal to 2x squared, y prime will be 4x, y double prime will be 4. So that means y double prime minus y equals 4 minus y. So 2x squared, boom, yes. So yung y sub p na 2x squared is indeed a particular solution to y double prime minus y equals 4 minus 2x squared. Okay? Kaya lang, hindi lang ito yung solution. Kaya ang tawag natin dito ay particular solution. Kasi isa lang to dun sa mga solution ng ating ng non-homogeneous GLDE. Meron pang ibang mga nagkukubling solutions. Alright? Sino-sino sila? Well, kanina, nakita natin na sabi dun sa superposition theorem, ang tawag sa kanya ay superposition. Kasi ang ginagawa natin, ina-add natin yung solution sa dun sa yung isang particular solution dun sa non-homogeneous GLDE dun sa general solution ng homogeneous GLDE. So aside from solving for a particular solution to the non-homogeneous GLDE, kailangan ko ring isolve yung homogeneous version. Kasi ang value nito ay lagi nagze-zero, so it doesn't matter kung ano yung it doesn't matter kung isusuperimpose ko siya dun sa particular solution. Kasi yung y double prime minus y naman dun sa mga y sub c ay laging equal lamang kay 0. Okay? Oh, pero paano natin ito isosolve? Nakita na natin dito. Nakita na natin kanina na ang particular solution, ang general solution to y double prime minus y equals 0 ay c1 e to the x plus c2 e to the minus x, right? So this means that our general solution to this non-homogeneous GLDE ay si y equals particular solution plus c1 e to the x plus c2 e to the negative x. Ito yung general solution niya. According to the superposition principle or the superposition theorem kanina. Okay? Bakit yan? Yung solution, well, kaya niyo yung i-verify. Kunin niyo lang yung y double prime minus y. Simplify natin, right? So second derivative. So second derivative ng 2x squared plus c1 e to the x plus c2 e to the minus x minus 2x squared plus c1 e to the x plus c2 e to the minus x. Right? Para ma-verify talaga natin na sila ay solution ng GLD. Well, one thing I can do is I can distribute the second derivative, all right, over the sum. So pwede ko itong isulat na second derivative ng 2x squared plus second derivative ng c1 e to the x plus c2 e to the negative x. Ito na rin yung sketch ng proof kanina, ng superposition principle. Alright? Tapos ito, second derivative ng 2x squared minus 2x squared. So basically, that's y double prime minus y. Alam ko particular solution siya nito. So ito minus ito ay equal sa 4 minus 2x squared. Right? Kasi alam natin si 2x squared, particular solution ng y double prime minus y equals 4 minus 2x squared. So kapag kinuha yung second derivative niya, minus yung sarili niya, ang sagot dapat ay 4 minus 2x squared. In principle. Or you can just simplify this, you get 4 minus 2x squared. Tapos, second derivative nito, minus sarili niya, ay equal kay 0. Kasi general solution siya ng homogeneous differential equation. So basically, this terms in green is basically y double prime minus y, which is equal to 0 kasi nga general solution sila ng homogeneous version. So this guy will simplify to really 4 minus 2x squared. Ito yung proof na indeed siya ay solution. Pero ganito yung pag-solve ng non-homogeneous GLDE. Una, kailangan mong humanap ng particular solution, which could not be easy. Pero on top of that, we need to solve the homogeneous version and find a general solution to it. Paghanap ng general solution sa isang order n GLDE, kailangan natin ng n na linearly independent solution. Sila yung isusuperimpose natin o kukunin natin yung linear combination. Pero dapat sure tayo, linearly independent yung mga solutions ng homogeneous GLDE. Alright? Paano nag-check kung homogeneous ang isang set of solutions? Kunin niyo yung Wronskian. Dapat yung Wronskian ay nagiging 0 sa at least isang number doon sa interval. And that pretty much sums up yung ginawa natin in the last 1.5 hours. Okay? So medyo maraming nangyari, but this will be the principle. This will be the blueprint us going forward sa pagsosolve ng mga general GLDEs. Kamalas-malasan kapag non-homogeneous. Kasi kung non-homogeneous yung GLDE, dadaan pa rin tayo dun sa homogeneous GLDE. May additional step pa nga siya. Kailangan ng particular solution. But that's a preview to what is to come, all right? But at least now we have a blueprint. Ito yung goal natin. Humanap ng solutions, ng linearly independent solutions sa homogeneous GLDE, tapos humanap ng particular solution sa GLDE as a non-homogeneous GLDE. And that would be what we'll do in the next half of the semester. All right? Okay, so we can stop here. Any questions? Everything's fine? Ready nang magbakasyon? Or sir, what's vacation po? Na mag-aakads pa rin kayo over the break. Oh yes, Victor.
Sir, yung doon sa Wronskian, sir, if ever na hindi siya triangular matrix, pwede ko i-transform into triangular matrix?
Yes.
Or magkaiba ba yun labas?
Depende sa transformation na gagawin mo. Paano mo siya ita-transform? Kasi kapag halimbawa nag-interchange ka na ng may effect kasi yung pag-i-interchange ng rows at columns. I think pag ano ba nangyari? Yeah, I need to check. Nakalimutan ko na sa linear algebra. Kasi parang pag nag-interchange ka ng rows o kaya columns, kasi parang ang nakikita kong gusto mong gawin ay i-rearrange yung matrix para maging upper triangular or lower triangular siya. Double check kung ano yung effect ng pag-i-interchange ng rows. I think pag nagsuswap yata, namumultiply ng -1 or hindi. I'm not sure. Basta parang may effect yon. Pero sure ako na kapag ka nag-multiply ka ng scalar sa isang row, namumultiply yung scalar na yon yung determinant. So pwede naman, pero take note ng ano yung nagiging epekto ng transformation na ginagawa mo dun sa matrix, dun sa kanyang determinant. Yeah. Pero usual technique ngayon, ang ginagawa sa linear algebra, nagta-transform ng isang matrix sa kanyang posibleng reduced row echelon form or nag-LU decomposition para sa mga nag-175 dyan para madaling mahanap yung determinant. Pero don't worry too much about the determinant. Dapat madadali lang or basic lang yung ipapadeterminant namin sa inyo. Papahanapan ng Wronskian. Kasi nga, you are not expected to know the advanced techniques sa pagsosolve ng determinant. Yung mga sinasabi ni Victor na nag-interchange ng rows or columns, transformation to an upper triangular or a diagonal matrix, medyo advanced linear algebra na yun. Pero pwede yun, Victor. Just take note nung ano dapat yung ano yung nagiging epekto ng changes na ginagawa mo at every step of the way. Right? Yeah, nakalimutan ko ano nangyari pag nag-interchange ng rows. I'll need to check on that. I need to brush up on my linear algebra. Pero that's the case. Tapos kung gagamitin yung mga techniques na yon sa homeworks or sa exam, i-indicate nyo na natutunan nyo siya somewhere else. So pwede nyo sabihin, by a technique learned in linear algebra, I can do the following to get the determinant. Para lang alam ko na, may pinagugutan tong bata na to dun sa solution. Okay, other questions? All right, so if there are none, so guys, I hope you find a restful reading break. Enjoy it and maximize it, just to re-energize yourselves, or kung talagang gusto nyong mag-catch up sa ACADS, then do so. But please find some time to relax and breathe. Kasi once we come back, we will be on the home stretch of the semester na. All right? So until then, guys, keep safe and have fun. Bye-bye.